everyone, this is Shatrupa and today we are going to see how to take input in a TCS online test, okay, because we do face a lot of trouble at times. So first thing we'll start with is the array, how we'll take input into an array, and we'll see how to take an input into a string as well, okay. So first thing is the array, and then we need to check there are different types of input that you need to take. So the case 1, it will be something like this: 1, 2, 3, 4, and 5, right? The space separated one basically. So how do? You do def and say input array format. Okay. So I don't know why I wrote that big name, but okay, that's fine. So ARR, then you're going to take a list. You'll use map, and then you will do int input. Okay, that's it. Now, once you do this int input, you are going to do strip. Now, why do you use strip? So it is going to ignore the bracket that you would have provided. Okay, it will exclude this bracket. Okay, then what will you do? You will use split. How will it split? It will split. Okay, I'm sorry. We'll consider this first case to be. Let's consider comma separated. Okay, we'll go to the space separated next. 4 comma and right. So how will you split? You will split it using a comma. Okay, so that is exactly what you need to do. And finally, what will you return? You will return ARR. Nothing more than that. All right. So next will be your case 2. Now in case 2, it's just the values with space separated. Why did I fix this with comma? Because if you have space within this square bracket, it won't take that. That is not the right input. Okay, so if you're using a square bracket, you need to put the comma. Okay, then 3, then 4, then 5. And how do you know how to take these input? You need to look into the question for examples or input output sample test case. Okay, now once this is done, what will you run? You will run def. Let's call this space separated, maybe separated, right? And we will say ARR is equal to, again same, you need to create a list and a map, and then what will you do? You will do int followed by input, right? Because you're taking an input, and now you are going to just split it. And if you just do this, this will split it by the space automatically. Okay, and finally just return your ARR. All right, so the third case will be where it is like this: there are no square bracket, but there is a comma, right? Something like this. So in this case, what will you do? Again, simple. Okay, I'm just going to copy this, paste it here, and instead of this, you're just going to put it up as comma instead of the space. And let's just change the name so it does not throw an error to say comma separated. Okay, so it will be same list map int. You're taking the input, then split and return ARR. One key thing here: do not use any statement like enter the value of the array, enter the age, enter the name. No, because no physical human is actually entering or going to run your test cases. This will be run by a computer. They'll simply upload the CSV file, and it will run all the test cases. Okay, so if your compiler gets stuck on the statement of the print because it doesn't know what to enter, your code might not satisfy all the test cases. Okay, so keep this in mind. You do not have to use these things. Okay, now there is one more thing that you need to figure out. What's that? That is case 4, when size is not given. Okay, so it's very simple. You can do it in 2 ways, not complicated at all. So suppose you take sorry, need to define a function. So say define input not given. So well, you can do this in 2 ways. I will show you both. So we are doing the complicated one, which I don't usually appreciate doing it, but you can give it a try if you think there can be an exception. So you'll use a try catch block, try except block, not catch, but okay. So if your num is equal to your input dot strip, okay, what you'll check, you will check if num is equal to empty. Then just break, okay? Else, what you're going to do, you're going to do arr dot extend. You're going to increase, okay? This is for the dynamic use of array. Extend int comma num dot split. Fair enough? Now, there's one more thing that you will see here is called as the except. So it will throw an value error. So wherever you think that there can be a exception, use this, okay? So what will you do? You will have please enter valid integers and you will return ARR, okay? Now, there will be one more thing in which you can do a case 5, which is also same size, not given, but this is something I would prefer. Why? Because it's just the same like what we did. So suppose we take this input not given to lists int. Okay. So if you consider these things, these definition, your input wasn't given, but you were still doing it, right? Why did I do this? Just to show you that you can use a try catch if you think there will be a value error or some exception can occur. All right. That is the only motive of this, okay? And you can just add one more line over here saying print this, okay? So all of them can work. Now the next thing we look into is the strings, how to take an input for strings. Now it is also same, okay? I mean it's same for 99% of the stuff, so we will just copy it from here. To copy these, okay, and we will paste it. Okay, so what is changing here? So first the input. Okay, we'll change this to say A, delete this, make it B. Oh, it's not adding double. We already have a comma. Okay, and similarly this will change to C. And similarly this will change to D. Well, you can keep it for also within the quotes. Within the quotes, if you have anything that becomes a string. But anyways, just to make sure that it's all clean. So what will you do? You will do input array format again. We are calling that same function. Or you can just change this to input string format. So you'll take a list, a map, and instead of int, you will just change this to str, the string format, okay? Then input strip will remove your square bracket and it will split from the comma, okay? Now this should be space separated. So A, B, C, D, and E. All right. So if this is how you have entered, again, this will be space input, let's say string, space separated. So again, it will be ARR list map instead of int, it will become str. Then it will remain the same. All right. Now, this is also going to be the same. You're just going to change this to str. And if you want, you can change all of these to this. And it will be string comma separated. All right, that's it. Now, there is one more thing that we need to look into, that is case 4. What is case 4? Input size not given. So input size isn't given on the top also, but this is specifically when you encounter a thing like an array or a list or something like that. So what will you do? You are going to create a function def input string size not given. Okay, you definitely not taking this big name in your exam. This is just for your understanding, okay? So you'll create an empty thing, the list, ARR, and you will do while true. While true, what are you going to do? You are going to check if the element is in this format, okay? Like you are basically going to do input dot strip, okay? Because you don't know in what format it is given. So you will do if not element, then simply break, okay? And otherwise, what will you do? You will append your element and return ARR. Okay, and this will be your final thing. Okay, and this is how you can print it. All right. So I hope you guys have understood. This was helpful for you guys, right? Now there are few things, few tips that we need to look into. There are two and one I'll give you at the end. So the first one is indentation error. Okay. So always use two blank spaces and do not use the tab. Okay. So what will you do? You will write if a equal to 0 colon, press enter, use the space bar. Okay. Give two spaces, write this, b equal to 9, press enter again. Give two spaces using the space bar. Do not use tab. Okay. C equal to 5. Press enter. Else press enter. Two spaces using the space bar. Okay. So this will avoid your indentation error. And one biggest thing that I have already mentioned is do not print anything while taking the input. Okay. That is x is equal to input entered age. Don't do this. Okay. Because no one is going to read that. And if your compiler gets stuck in this stage, it is going to create a problem. Okay. What will you do? You will simply take this. Okay, simply do this. That's it. All right. One more thing that I would like to add here is the segmentation error, right? We have often encountered segmentation error. Now, what is this? So see, the compiler is specifically designed by TCS for the TCS exams. Okay. So if you are encountering a segmentation error, that means you are using a function that the compiler is not aware of. Okay. So what is your best way to do that? Always stick to the common functions. In general functions, the simpler function that we have been using in everyday coding. Okay. That is how you can avoid your segmentation error. So these are the three types of error that you can encounter: indentation error, runtime error when it won't be able to process your print statements, and segmentation error. All right. So I hope that this video was helpful. You have understood how to take input in arrays and string. Mostly you will get question 99% of the times from arrays and string. And even if it's not from arrays and string, it is from some other thing. Your input still remains the same. You're still going to take the input in this way. Okay. You are not going to change how you take the input. Right. I hope you have understood, you have the clarity. I hope you can do well in your exams. I will see you in the next video. Until then, keep learning and thank you. This question says that find the subarray. Okay, find the subarray. Actually, it should be subarrays whose sum is equivalent to the given target. Okay, so you have an array. You have been given a target. So you need to find the sum subarrays of this existing array whose target is equivalent to the sum of 7. Okay. So if you see, the first output is 3 comma 7. The next is 3 plus 7, 3 plus 4, which is 7. Then minus 7 will be 0. Then plus 1 plus 3 plus 7 will again make it 7. Okay. So the next one is 1, 3, 3. And then last one is 3, 3, 1. Now what is a subarray? It means it is a continuous array. Okay. It can't be discontinuous. So you cannot say that I will choose this 3, then this 3 and this 1. No, it's discontinuous. Then what are the values? If you see, one is here, the other one is here, then the next one is here, and the last one is here. Okay, they are all continuous. The first factor of a subarray is that it must be continuous. All right. Now, by reading this question, you would have understood that the best and the simplest way would definitely be brute force. Right? But how do you implement this brute force? Now, I have the array 3, 4, minus 7, 1, 3, 3, 1, and minus 4, right? This is my array. Now, I will consider an index I and I will consider an index j, both starting at 0. So, I equal to j equal to 0. Okay. I will also consider a value called sum, or rather current sum, okay, which will be assigned to 0 initially. Okay, so I will hold my I over here and I will traverse my j across this loop. Okay, I will traverse this across the array just to make sure With I, what all pairs could make a combination of the given target? So basically, I'm going to traverse that and I will see that, okay, I is 3, j is also 3. So if I do I plus j, that is 3 plus 3, will it be 7? No. So just increment j plus plus, do nothing. Now I is equal to 3, j is equal to 4. Is there some j plus I or I plus j equal to 7? Yes, it is. So what will you do? You are simply going to print the array from I all the way till the array of j plus 1. Now why j plus 1? Because if I do j, then it is not going to consider this position. It is just going to print 3. But that's not the case, right? We need this one because the other half is always exclusive. It's like if I write range 0 to n, that means n is excluded. It's not included. It's going to consider the value of n minus 1. So similarly, if I want to include j, I'm going to write j plus 1. All right. So it's as simple as that. All right. But if you actually consider the time complexity, what will be your time complexity? You are running a loop inside another loop. So this will be your n square, right? So your time complexity will be big O of n square. And your space complexity will be a constant because you're not really storing anything, right? So that is why this approach is discarded, but we'll still see how to run it in this approach. Okay, so say we have a function, let's define, call it as brute force. All right, and what do we pass? We pass ARR, we pass n, definitely the length, then we pass the target. All right, and we are going to run a loop of I in range of n, right? It's going to start with 0 all the way till n. That means n minus 1. N is excluded. Now, once you have done this, we are going to assign a variable called current sum, which will be equal to 0, right? Now, here we'll start running a loop called j. This will be in the range of I, comma n. Why n? Because n will be excluded, so it will run starting from I all the way till n minus 1, which is fair enough. Now, what are we going to do? We are going to do current sum plus is equal to ARR of j. Okay, so instead of actually using I, because it's a loop variable, we created another variable called sum that is also pointing to 0. So we are going to run this. And what are we going to do? We are going to compare if our current sum is equal to target, right? Then what will you do? You will just print ARR of I, like the array of I starting with I all the way till j plus 1. All right. This is what you will do. And that's your loop, the whole function. Now let's create an array because we don't have one. Suppose I make this a list and say, let's just do this, okay? And so basically it's list, then we map it. It's an integer type. We take the input and we split it. We take the n, that is the length of the array. And then we take the target, which is again going to come from the input. And finally, we call brute force. We pass the ARR, we pass the n, and we pass the target. Okay. So just to keep a difference between this n and this global n, where we are going to take the input, just change it to capital N, though it really doesn't matter. Okay. So now we are going to run this, but before that, I need to connect this. So once connected, we'll run it and we'll see how it actually works in brute force method. So there we go. So we'll enter the same value, that is 4 comma minus 7 comma 1 comma 3 comma 3 comma 1 minus 4, right? And now we'll enter the target. Okay, what will be your target? Your target will be 7, and there you go. 3 7 3 4 3 4 7 1 3 3 1 3 3 and 3 3 1. Okay, now if I rerun this, let me copy this first. I don't want to type the whole array. and we enter a number whose sum doesn't exist, it's not going to return anything. Okay? So this, I mean, sum exists. It's not like 10 is not there, 10 is there, but it's a subarray, right? Subarray has to be continuous and it's not there continuously. Okay? You can definitely have 3 from here, then you can have 1 from here, and then you can have 3 and 3 from here. Now this is continuous, but this 3 makes it a discontinuous thing, so nothing will be printed. All right? But again, we just spoke about, right? What is the time complexity here? Time complexity is big O of n squared, which is too high. Space complexity is still fine. It is just a constant thing, but your time complexity is too bad, right? So very low chances that this code will be accepted in the exam, right? So how do we solve this issue? We use something called as hash map. I don't know if you people have watched the data structure video on hash map, but this is a very brilliant example of hash map. Okay, so we have the array 3 4 minus 7 1 3 3 1 and minus 4, right? So what will we do? Instead of that looping variable j, we'll simply use cur sum. Okay, now what will your cur sum initially be? Initially your cur sum will be equal to 3. Why? Because it's just going to store the value. Okay, and you will have a map. Okay, you will have a map. Now what does a map store? Map is basically a dictionary, right? If you remember, map is nothing but a dictionary. So it will have the key, that is 3, and the value, that will be the index. This is the key which is storing the value, and this is the value which is storing the index. Okay, I will just change this value to element, so avoid any kind of confusion between value and value. Okay, once this is done, what will it do? It will increment I, right? So once it increments I, what will your current sum do? If your current sum is at 3. Now this, once this is increment, your current sum will also store the ARR of I. Okay, so which is equal to 7 now, because I is at 4, right? 3 plus 4 is 7. So it's going to store 7 comma 1. Now it will see that this cur value is equal to our target. So what will it print? It will again print the array starting from 0 all the way till ARR of I. So it will print 3 comma 4, right? Again, similarly, this I will be incremented. All right, so now your cur sum will be over here. So it's already 7. 7 minus 7 will make it 0. And it's going to store 0 is to, what is the index? This is 2, right? 0, 1, 2, 3, 4, 5, 6, and 7. So it's going to store 2, right? Now this is not equal to the target, so it's going to just ignore it. Then I will be shifted. And so once your I is shifted, okay, I mentioned 0 here because my current sum was pointing to 0. Okay, now where is my current sum pointing to? My current sum is here. Okay, and my I has been shifted because we upgraded my current sum, right? Keep that in mind. So once that is done, it became 0 here. Now your current sum is 0 again plus 3. Nothing will happen. But do we have 3 already inserted into this? Yes. So we are not going to repeat that key. Similarly, it will keep going ahead and it will find another subset that will be 1 comma 3 comma 3. All right. Or rather it can, and it will also find this subset. All right, but how much time will this take? This will go on and on and on, okay, till we reach the end of the loop and it finally goes out of bound. So what will be the time complexity here? Simple, for just, we are just using one loop to just loop over. So time complexity will be big O of n, right? And what will be our space complexity? That will also be big O of n, because we are storing, in a way, we are using this map to just make sure that there is no repetition of elements and we are storing it properly. All right, so both of them will be big O of n. And it is better, definitely. You always compare the time complexity. It is definitely better than the brute force that was n square, right? So this is what your time complexity and space complexity will look like. Now let's go back to coding, and we will define a new function called, say, uh, optimal approach, maybe optimal code, right? Optimal code, and we will do ARR and pass the same target. Okay, once we are done with that, we are going to have a sum map. Map is exactly where we were storing those stuff. And since it's a dictionary, it comes with the set of curly braces. And we'll also have the cur sum, which will be equal to 0. And this is going to store the sum, right? So we'll do for I in range, definitely n. So it will go all the way till n minus 1, right? Then what are we doing? We are just adding that cur sum. We are adding it with the element at ARR of I. Okay. Now, the first thing will be simple. If your target is equivalent to the cur sum, if your cur sum is equal to the target, then what are you going to do? You will simply print the ARR, okay, all the way from 0 all the way up to this. Okay, if the target is found. Got it? Then, if your current sum minus the target is in the sum map, then we do not append it. Okay, is in the sum map. Then what will you do then for cur sum? Or rather, let's take a new index, say start index. Okay, start index. We just do a better naming here. Start index. So what will you do in sum map? You're basically going to do cur sum minus the target. All right. And then what will you do? You will simply print ARR. And what will you have? You will have the start index plus 1. And till where will you print this? All the way till I plus 1. Why I plus 1? Because again, if you just do I, it will become excluded, and we don't want to exclude it, right? Now, the last thing, that if your cur sum is in the sum map, okay, if it's here, then what will you do? You will simply do sum map of cur sum, and you gotta append it where? Along with the I, pen dot I, right? And if that is not the case, you just do else sum map of cur sum will be equal to the index of I, right? That's it. Okay, and we will run for something. What was the function name? Optimal code. And we are going to pass ARR, comma N, comma the target. All right, and we will comment this brute force out, and I'm just going to copy this array, and let's run this. Okay, same, and we give the target 7, and we are getting this. Okay, but the only difference is that this will happen in big O of n, right? That is the only thing, that this is going to be a more optimized one, and this will happen in big O of n, though the space taken here will be more than constant. That will also be big O of n, which is not bad, which is fine, fair enough. Okay, all right. So this is the total code, and yeah, this was a question asked in TCS probably previous year. And this is how you solve it. You have to solve it rather in an optimal way rather than just using brute force, right? So I just commented brute force out so it doesn't run for brute force, but it just runs for optimal code, okay? Which is a pretty high level because till now it's categorized as a medium level question. And these kind of questions are pretty common in Google, Microsoft, and Amazon. And TCS somehow managed to ask this question because the competition is tough right now. Okay, it's getting serious day by day. So yeah, let's see how we actually solve this question. This was asked as a previous year question. The unique paths, right? It's a direct question from lead code. So we are going to solve this in lead code and not on Google Colab. So we'll see how this goes, okay? So it's basically a game and you have to find the path in which the robot can move from the start location all the way till the finish, okay? So it says there's a robot on an M cross N grid. So you can see the grid and it does not specify what is the size of this M and N, okay? The robot is initially located at the top left corner, that is the grid 0, 0. Okay, this is grid 0, 0. The robot tries to move bottom right corner. So it can either go down or it can go right. It cannot go up, it cannot go left. Okay, the robot can either move only down and right. That is what it meant by bottom right corner. Okay, given two integers m and n, return the possible unique paths that the robot can take to reach the bottom right corner. Okay, right here. Test cases are generated so that answer will be less than equal to this. Now, this is the time complexity, and you have to make sure that your time complexity is less than this, and we'll see how. So, this is the input. As an example, it's given m is 3 and n is 7. So, if you see m is 3, like 1, 2, 3, and this is 7. All right, the output has to be 28. Okay, how is that happening? Now, let's go and get this evaluated. Okay, now the example says that your m is 3, n is 7. Okay, so that means your m is this, right? And your n is this. Okay, that's your m cross n grid. Now let's call this dp, this whole grid as dp. Okay, so where is your robot standing? It is standing at 0 comma 0. Okay, this grid, this location is 0 comma 0. Similarly, this is 0 1, 0 2, 0 3, 0 4, 0 5, 0 6. Okay, similarly, what will be the ones at the bottom? It will be 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, and this will be 2 0, 2 1, 2 2, 2 3, 2 4, 2 6, and 2 7. Okay, so it said when the grid is m cross n, sorry, that is 3 and 7, your output is 28. Now let's understand how is this happening. Okay, we get rid of all the indices that we wrote. So we know the start is 0 0, right? Now a very simple implementation of this will be that you can only go down and you can go right. The robot cannot go left or cannot go up. Okay, what does that mean? So if the robot starts going this side, in how many ways can it go this side? One. Then if it goes to the next this one, how many ways can it go? One. To next this, how many ways? Just one way, because it cannot go from here, right? It cannot go down, and because it can go down, but it can't go up again, right? So that is why it's just one way of traveling, that is this. So for the whole line, it's going to move in one way. And similarly, if I go down like this, it's going to move in one way, right? Because it cannot move down and it cannot go left. It will move down, but then it can't go left. Okay. So this will have one path, this will have one path, and these all will have one path. Okay. Now, this is your base case. This structure is your base case where everything is in 1, 1. Okay. But you know what? You really don't have to assign everything as 1 1 for your base case. What you can do, you can simply assign dp of 0 0 to be 1. If you just assign this one to be 1, let me use a darker color because it's way too dark. Maybe a black. Okay, so if this is your 1, then definitely everything this side on the top row and everything on the left column will be 1. How? Because how is the sum being done? If you actually see, what will be this value? This value will basically be this plus this, because it can come here and it can go here. So how many ways will it go? It will can reach this position in 2 ways, right? Now, if you talk about this position, in how many ways can it go? It will go in this plus this, because it can go this way and then it can come down from here, and then it can come here and come here, or it can come from here and it can come here. So it will be 3, right? Similarly, what will be the number for this? This will be 4, because sum of this 3 and 1. Similarly, for this it will be 5, 6, 7. Okay. Similarly, this, in how many ways will this happen? This will happen in 1 plus 2. How much is it? 3. Similarly, 3 plus 3, this will be 6, this will be 10, this will be 15, this will be 21, this will be 28. So if you remember, the lead code output said that if this is the grid, then the output will be 28. Right? This is how we got 28 unique parts. Okay? But why did I actually assume this to be 1? Because if you consider the grid, if I'm actually doing it this, the left one is the top one, then how is this 1? Because the top for all these are out of bound. We don't have anything. We don't have an array on top of that. So we have to explicitly assign all those values to 0, else it will throw an error. Okay. Similarly, we have to assign all these values to 0 explicitly. Similarly, we have to assign all these values to 0. Right? Similarly, these will also be 0. So your extreme left, your extreme top, your extreme right, and your extreme bottom, they all have to be assigned to 0 explicitly. So there is no confusion while you add it. Okay. So now when this is being summed, oops, when you're doing a sum of this position, what are you doing? This number plus this number. Now this is explicitly assigned to 0. So 0 plus 1 is 1. Now 1 plus 0 will again be 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 1. 1 plus 0 will also be 1. Right? So that is exactly how we figured this whole thing out. Okay, now let me just clean the board. So we have little space. So what did you understand? Like I just showed you how we arrived at the answer, right? How we arrived at 28, which is fair. But what do you think? How was the path? So the path was something like this, right? The path was like this. And your D of 0, 0 is 1. Now, what can we do? This is basically nothing but dynamic programming question, okay? And it's very shocking that TCS has asked us, but it did. So dynamic programming, if you have not seen the video of data structures in dynamic programming, I request you to go and see that. So you can actually do it in 3 different ways, okay? Because dynamic programming has 3 different things. First, implement the code in naive approach, the normal approach, no DP, okay? No, simply no DP, okay? Do the next one in top-down approach, which is called as the memorization. The next one is the bottom-up approach, okay, which is called as the tabulation. These two will have the same time and space complexity, but still this one is easier or preferred because this one uses recursion, and many programming languages are not good at recursion. Okay, even this one will use recursion, but this one will have the use of recursion in a better way, right? So let's just look how we code this. Now we are going to use all of them together. Okay, so the first one definitely is the naive method where you don't use recursion. Oh, sorry, you already have the definition, right? Yeah. So we'll just start Simple. Okay, so the first thing will be you will define paths. Okay, let's define paths, that is I comma j. Okay, now if I is equal to j, which is equal to 0, why we are starting at index 0 0, that is where our robot is, then do what? Simply return 1. Okay, as I said, this will be your base case. Okay, just explicitly assign it to 1. Else if your I is less than 0, or your j is less than 0, or your I is equal to m, or your j is equal to n. What is this? This means your extreme top, extreme left, extreme bottom, extreme right, all of them will return. What will it return? We just spoke about it. They'll all be assigned to 0 explicitly. Okay, so we don't run into an error, because otherwise it will give array index out of bound error. Okay, simple. Do what? You return paths, that is I comma j minus 1. Okay, then what do? You do a sum of paths again. This will be I minus 1 comma j, right? And then finally you return paths, that is m minus 1 comma n minus 1. Okay, that's it. If we run this code, uh did I miss some? Oh, I'm sorry, this should be in the next. We just came one ahead. It should be inside this. Yes. Oh, I did a spelling mistake again. It's going to throw an error. Return. Okay, so now let's see. It should be good to go. Yeah, accepted. But if you actually submit this code, right, you will see your time complexity will exactly be what they had given here, 2 times 10 to the power n, right? Your time complexity is too bad. That is what it says. Time limit exceeded. So, what is your time complexity here? Your time complexity is basically big O of 2 to the power of m times n. Okay, and this is a very, very big time complexity, which is really bad, and we don't prefer using it. Okay, and what will be your space complexity? I guess space complexity will just be your big O of n times n, which is still very bad. It's not a good one, right? So what do we do next is we do a better approach. And what is that better approach called? It's called the top down. Okay, top down approach. And we use memoization. So basically we'll create a memo in which we'll remember the paths that we have traveled. Okay, that is as simple as that. So how do we store the memo? We'll store the memo in a dictionary. And what will be the first element? It will be 0 comma 0. And what will be that assigned to? That will be assigned to 1. Right? This will be the initial base case. Now we'll have defined paths I comma j, and then we'll do if our I comma j is in the memo, right? Because we are remembering all of that. So is in the memo, then what will you do? You will return what? You will return memo of I and j. That's it. Right? You will return memo of I comma j. Right? Else if else if your I is less than 0, or your j is less than 0, or your I is equal to m, or your j is equal to n. So what are these? These are again the extreme left, right, top and bottom cases. These all should return 0. Okay, explicitly we have to assign that. Now else, let's take a variable val which will store paths of the same thing. Okay, it's I comma j minus 1, and then what? Paths, sum of the paths of I minus 1 comma j. Okay, and then you will do memo, and you will just assign the value of memo to val. Okay, so we don't want to fiddle with memo. So we'll just assign its value to val and we'll return val. Okay. It doesn't matter. You can return memo also over here. Okay. I just don't want to do anything with the memo thing. I just want to keep it untouched. So that is why I wrote this. Else you can return memo as well. It won't be an error. So similarly, the return will be same m minus 1 and n minus 1. Now let's run this. Okay, so this is also accepted because the code is correct, definitely. Now let's see if the time limit will be exceeded or not. It is accepted. Okay, why? The reason is the time complexity is equal to basically big O of m times n. Okay, and your space complexity is same like before that we had in the naive approach. It is also m star n. Okay, so this is better than 2 to the power of n star n. So that is why it's accepted. But now there is one more method in which we can do, that is called as the bottom up approach. And like I mentioned before, the time and space complexity will still be same. It's just that it is going to avoid recursion. Okay, just that it will avoid recursion and use tabulation instead of that. That's a list. So it gets easier when we actually evaluate on certain things. Okay, so we are going to get rid of this. Now how do we start with this? This is going to say dp, make an empty list. Like I said, we don't use recursion, we use a list. So we'll do for in range. What is your range? Definitely n. So then what did you just create? You created the number of rows. You need to create the number of columns now. What will you do? You will do append 0. How many times will it have 0? N times. Okay, whatever your n value will be. So what did I do? I created a row of m and then I made columns also, but I initialized all the columns value to 0. Okay. Now once this is done, you're going to run your base case, that is dp of 0 0 will be equal to 1. Okay, then for I in range of your m, what will you do? You will run a j in range n. Okay, now if your I equal to j is equal to 0, what will you do? You will just continue. Why? Because we just don't want to do it for the base case. We just want to skip the base case. Okay, now after this, what will you do? You will take a value, assign it to 0, and then if your I is greater than 0, what will you do? Oops, sorry, I missed that. What will you do? You will do val plus your, what will be your value? It will be your value plus the dp of I minus 1, then j. Okay. Similarly, if it is for your j is greater than 0, then your the sum of val will be the sum of dp of I of j minus 1. Okay. So the first one will be I minus 1 j. The next one will be for I j minus 1. Cool. Now dp of I j. Okay. What will be the value? It will be valid. The same as assigning a memo thing that we did. Okay. You can return anything that we want, but we are not going to return this. Why? Because it's not a recursion, right? So we'll finally just return what we need, that is dp, same m minus 1, n minus 1. Okay, that's it. That is all that we have to do. Now let's run this. Okay, this is done. Now let's submit this, and you will see this will have a lesser time, right? Runtime is this, and it beats 88% of whatever the answers have been submitted, right? Why? Because just a direct thing, we used tabulation and no recursion in this. But however, your time and space complexity will be same as that of top down approach. There won't be any difference in that. So keep that in mind. Okay, it will be same as big O of m times n. All right. So with this, we come to the end of understanding this question. It wasn't a critical question, pretty simple, but you need to really understand what's happening and how you can apply. So if you ask me, do I have to implement all three of the code in the exam? No, you do not have to implement. But if you implement the first one, the complete recursion one, the naive method, then it will not be accepted because that is what it says. It has to be less than this. Okay. So either you have to implement the top down approach or the bottom up approach. If you ask me what I prefer the bottom up approach because there's no recursion. All right. It's simple implementation of a list and two for loops. All right. So the question was pretty simple and easy, and this is something that we can definitely expect from TCS. So it said that find the sum of cubes of numbers given in a range. Okay. So how do you go about this? So suppose my range is, say, starting with 1, 2, 3. Okay. This is my given range where I say, suppose 1, 2, 3, or I will do the range to be 1 to 4. Okay. That means this one is excluded, right? This is included, this is excluded. So that means it is going to exactly run for 1, 2, and 3. So how will you find the value, right? How will you do the sum? Pretty simple to do the sum. So you take a I, definitely that's what we have been taking all lifelong. So you will put a value, say cube sum, assign it to 0. Okay. What will you do? You will go here. What is your I? I is 1. So what do you have to do? You have to first cube the I and then add it to cube sum, right? That's it. That's all that you have to do. And you have to keep iterating. Once done, keep iterating to the next until you reach the end of the loop, right? So once you are here, what will you do? What is the cube of 1? It's 1. Now you're going to add this to this. So what will be your cube sum? Your cube sum will become 1. Now you have to do I plus plus. Now what is the value of your I? Your I is equal to 2, right? When your I is equal to 2, so what will be your cube sum? Cube sum will be equal to cube sum, that is 1, plus, what is the value of I? 2 to the power 3. So it will be 1 plus 8, which will be 9, right? Now your cube sum is equal to 9 plus, you have already done I plus plus, okay? I plus plus after this. So what's the value of your I now? It is 3, right? At this point, your I is equal to 3. So you will do cube of, sorry, I just wrote the cube. I'm sorry. So you will just do cube of 3, that is 9 plus 27, right? Now, once you have done this, what will be your next step? It will be I plus plus. The moment you do I plus plus, I goes out of bound, right? So if you see, we ran from 1 to 4. 4 is excluded. So the moment I do I plus plus, it's going to go out of bound. And this value, that is 36, shall be returned. Okay. It is as simple as that. And since we are just going to run one loop to iter over the given range, the time complexity will be big O of n. And we really do not store anything. So our space complexity will be a constant. Okay. One thing that you really need to look in this is how have they printed your output? Oops, I'm sorry. How have they printed your output? Okay, how have they printed your output? So suppose your output has been printed like, say, like not the output, actually the input. Sorry, my bad. Input. So if they have taken input like this with space separated numbers, then make sure that is what your input statement looks like. Okay, but if they have taken input like one after the other, so make sure that this is what your input looks like. Okay. All right. So that is all that you have to know. So now going back to our collab and let's code this. So suppose we'll write the code, find sum, or rather let's name it find cube sum. Okay. And then what do we pass? We pass a start, that is basically your the range, beginning of the range, and we pass an end. Okay. Now once you do this, you're going to assign the value of cube sum to be 0. Okay. Now you'll run the for loop. For I in range, what will be your range? Your range will be start all the way up to n plus 1. Why? If we just write n, then n will be excluded. We want it included, so that is why we'll do n plus 1. Now, as simple as that, what are we simply doing? We are doing cube sum is equal to cube sum plus I. And how do we do the exponential thing? How do we put the power? We do it like double asterisk. Okay, so if you have not seen the Python video where we have discussed all the basic forms of Python to all the advanced level, I would request you to go there and just have a look. All right, and finally do what? Nothing, just print it. All right, so we'll print this. And now the important part that I was talking about, that is the how do you take the input. Okay, so if the input is given in the comma separated format, then simply do this. Okay, in just one single line you can do it. Say int, definitely int will be the only thing, and then you will split the input. So just use the split function for that, and that's it. Just call the function cube sum. Okay, and pass the start comma end. All right, so let's run this. Oh, I'm sorry, I didn't connect this before. Yep, so let's give a range, the one that we just did, say this and this, and then hit enter. It will send us 9. Okay, now if I run this again, and if I do 1 comma or space 3, it should return 36, and that was the value that we just found, right? Now, what if you don't want to do this and the input is given like vertically, one after the other? So you will do start is equal to int input, simple, right? And n is equal to int input. All right, and that's it. And we'll just comment this out because we don't want to take multiple forms of input. So we'll do 1, then hit enter, 3. This should give us 36. All right, I hope you got this. Now there is another way in which uh, you can directly do a formula thing. This is the formula, okay? So this is actually not 22, it's actually 2 to the power 2. So I'm sorry for the misprinting thing. So I'll just directly write the code here for you so you understand it better. So suppose I do this def find cube. Let's do a different one. Find some cube, okay? So we just keep the function names different and we pass say num, okay? And then I'll do I is equal to, now this is your formula. There is a formula in which you can see the mathematical derivations. I'm not into that, so I'm not going to tell you what the derivation is. How did we arrive at this? If you're keen about it, please Google it. There are plenty of research done on this, okay? So you will return, we'll do a int of I times 1. All right, and once this is done, we will do num, say we'll give num to be 3, and we are going to just print. All right, that's it. So if I run this, if you run this, you are going to get the value of 36. Okay, so this is, oh, did I, yeah, I ran the correct one. All right, so we are definitely not going to work with this, but yeah, this does have a very simple time complexity. The time complexity being equal to big O of 1, because you're actually not using any time, because it's a straight statement, executable statement, and your space complexity will also be 1 in this case. All right. So I hope that this video was helpful. I hope that you understood how to solve this question. But yeah, if you do it this way, definitely you are going to get I mean, your code will be accepted. It won't be a bad code. It's a very good code, because here the time complexity is happening in, sorry, your time complexity is equal to big O of n, right? And your space complexity is again constant. So pretty much what we want. All right, it's not bad. But yeah, if you know what the derivation and whatever thing are, you can definitely use this formula. But I don't know the derivation, and I honestly am not sure about the formula. But yeah, this is the code. All right. So you can give it a try if you want. You can put this as an user input as well, like this, and give it a try yourself. Yeah, but definitely this will have a time complexity of big of 1 because it's a straight formula execution, right? The question is right there in your screen. That is, you are given a grocery list which consists of 3 parameters: item, quantity, and price. Find the higher selling item, total selling item, and average selling item. So first thing first, we need to take an input. We'll do int input, and we are going to take input about number of items that will be there in the thing, right? Then we'll do store because just store, okay, in general, a common thing. So we'll run a for loop I in range of n. And what are we going to take input as? First, we'll take input as item, which will be given by the user, right? Similarly, we'll do it for the quantity. So quantity will also be given as user input. Okay, so if you want, you can hard code it, you can directly do it from your end. You don't have to, but I guess in the exams you can't hard code it, so because there will be test cases to run. But still, that's absolutely up to you how you want to do it while you practice. My main motive is to just tell you how to code, what is the logic. Okay, so once we are done with this, we will go ahead for the total price, which is equal to quantity times the price. Okay, once you're done with this, you are going to do store. You're going to do store items, okay, which is equal to store dot get. How will you do this? The get function uses the thing item by 0, okay, and then you will do total price. Okay, I made a spelling mistake. All right, so once this is done, we'll hit enter and we will do another thing that is called total is equal to 0. And once this is done, we are going to run another loop, and this will be a dictionary for key value pair. In what? In a store. Why? Because we created store as a dictionary. Okay, we have curly braces. How will we call the store items? By the items command. And then what are we going to do? We are going to do if max cost is less than the val. Okay, if the max cost is less than the val, then what will be your max cost? Will be equal to the key, right? And what will be your just the max cost? The above one was the item, so your max cost will be equal to the val, right? Now, I know we haven't yet defined max cost and val. We'll do that shortly. But yeah, after this, what will you do? You will do total, which will be equal to total plus value, right? And once that is done, you're going to exit everything and you're going to calculate the average, which will be equal to total divided by n, right? Because that is exactly how you calculate average. I, all right, there you go. And finally, we'll have the print. So what are you going to print? You're going to print first the item. So the bracket. I'm going to do a little detailed print, but you can just avoid it. Completely up to you. Okay, how you print it, but I'm just going to show you a little detailed way of doing it. So I am going to store my price in 2 decimal places. Okay, so I'm going to do dot 2f. That's going to show 2 decimal places. And similarly for the average price, I'm going to do it in the same format. I will do it again for 2 decimal places. Okay, once this is done, we are going to call the format keyword and we are going to do this. Okay, and finally close this. But as I mentioned, we haven't defined few things, so we are going to define few things here, like the max cost. We'll assign that definitely to 0. Then we'll have max cost item and we'll keep it as an empty string. And then we'll have total price. We'll have total price. We'll assign that to 0. And definitely you can have average. But I guess we have used, that's okay. You can just assign it to 0. Never mind. Okay. And with this, we are done with the code. Let's run this. And it's asking us for the first input. What was our first input? The number of elements. So here I'm just going to enter 2 elements. The next one has to be our item name. So let's say I'm entering potatoes. All right. The next one has to be quantity, say 2, and our price, say 20. Okay. The next item, because it's 2 entered, say orange. That's a weird grocery list, definitely, but okay. Say the quantity is 3 and the price is, say, 70. All right. So you will, okay, max val is not defined. So we need to define val as well. So let's just store val as, why do I have value while I've written val? All right. I was confused as well. I was like, wait a second, we just did that. So again, let's do it to potato and then we'll take it same. And then I guess it was 20. Then another one was orange. Then we'll say 3 and make that 70, right? So it will say the item with higher price is orange. The total price will be this and your average price will be this. All right. But why is this not a better way of doing it? Because when it comes to your time complexity, here your time complexity is equal to big O of n, which is fair enough. Oops, I don't want to run this again. So yeah. And the other one is big O of n, the space complexity. Now, in an optimal approach, you will see the time complexity will remain the same. We are just going to affect the space complexity. Okay, now this error is because I just stopped executing it. Okay, so we won't consider that. Now, let's write a better approach, which I find is much easier to do because we are not going to use 2 loops, rather just 1 loop. And it makes sense, right? So we are going to do the same thing and input, and I will copy it from here instead of just typing it again. Okay, so we'll have this. Now, what are we going to do? We're going to run that loop I in range. What will be your range? Your range will be again n, definitely for all the elements that you enter. So you're going to do item is equal to input, right? So it's again technically the same. So let's just copy it from here. We'll copy it from here and we will paste it here. Okay, so this part is done. Now, what is the other half that we have? We have to calculate the total price, right? Now, total price is equal to, this is the total price. Okay, so total price is equal to the quantity times your price, definitely, right? Now, once this is done, what will you do? You will run for if your total price is greater than the max cost. If this is the case, then what will you do? Your max cost item is basically equal to that item, right? And once that is done, just come out of that if condition and do average, which will be equal to your total price. But now this will be what? This will be I plus 1. Okay, because we aren't running another loop, remember that. Okay, and I'm going to copy that. Okay, we already have it here, so yeah, there you go with the print statement. Okay, so if we run this now, say we have to enter 2 items and we'll do it the same so that we can cross validate. Potato 2 kilos, 20 per thing. And then we'll have orange, that will be, say, 3 and it will be 7. Okay, so you got it. And the only difference in this code is that the space complexity is your I mean, it's a constant one. Instead of your space complexity being in big O of n, here the space complexity is equal to big O of 1. Okay. If you see here, the space complexity is big O of n. So the only better thing in this approach is you just improve the space complexity. Okay. But if you run both of them will be accepted. Definitely using two for loops will become easier because you actually are doing it step by step, following every single thing. But here it's fine, even if you just do it the way it is done. All right. This question was pretty simple, but asked in TCS. So yeah, let's have a look. So it just says that you have to take a three-digit number and check whether it is divisible by 9 or not. That's it. Very simple, right? But few things that you need to keep in mind. Point number one, take a counter when you take the input. Why? Because you need to see whether the digit entered by the user is three digit or not. Okay. So it has to keep track of that. Point number two is definitely you need to check for the conditions whether the number is divisible by 9 or not. And last thing is your output is a sentence. It's not a boolean value true or false. It's rather a sentence. You see, it says the number 236 is not divisible by 9, sorry. Okay, so it is a sentence. So you need to keep in mind these three things while you code. Okay, the code is pretty simple. Let's get started with that. So how do you do this? So we'll do def, just name it check divisibility. It's pretty big, but cool, fair enough. And we'll pass a number. Okay, once we do that, what are we going to check? The first thing is to check if that number lies between 100 all the way up to 999, right? So we'll do this number, then less than equal to 999, right? If this is the case, then again further we check that the number should be what? It should be divisible by 9, and that should be equal to 0. If that's the case, now what do? We return a statement. So we do print, we'll do a statement. So we need to use F. Okay, so it can combine integers and strings together, right? If you have not watched this Python command of how we use printf, refer back to the video. Okay, so we'll say that the number, which number? The number, this number, the one that we have taken, is divisible by 9. All right, that's it. And in the else part, what will you have? You will have the else part, which is not divisible, right? We'll just add here a not divisible by 9. That's it. Now what we need to do is we need to take an input. Okay, we need to take an input, say number is equal to int, definitely. Okay, input, and then we'll do check divisibility number. Okay, now let's first let me connect this and we can run it. So okay, so let's enter the same number 236 and enter. The number 236 is not divisible by 9. All right. So if you want, you can even add an extra line for invalid number. What if someone has entered a negative integer? Okay. Or if you don't want to enter a even it doesn't matter if someone has entered negative integer, you still want to perform the calculation, use the modulus of that number and do the division, right? So you can change this code according to the need of the question, but here I don't think anything was mentioned like that. So this is a very straightforward thing of doing it. Now tell me, what is the time complexity? So time complexity is a constant big O of 1, right? Because really didn't take time to do anything. And the space complexity is also big O of 1 because we didn't store anything, right? So that is all. I hope that this question was pretty straightforward, and I hope that those who have attended this question have done it correctly and you have gone step ahead in the interview process, right? All right, so the question says that given a list of numbers, that means an array, you need to return the maximum difference between the smallest and the largest number. Okay. Note that the smallest number should always come before the largest number, definitely. So if you consider this question, what will your first approach be? Sort it. And then you will have a min, you will have a max. Just find their difference, right? Simple. But this won't be optimal. Now, if you want to do it in an optimal approach, what are we going to do? I will just interchange the places of 11 and 8 so you have a better clarity on the understanding. So we'll have one thing called as the largest and we'll have another thing called as the max difference. Okay. Now what will be your largest? Your largest will start from here, the last element. So your largest will be 8. Now what will be your max difference? It's given that difference between the smallest and the largest. For now our smallest and largest is just one thing because we just have one element in the array right now and we are starting to traverse from backside. So it will be 8 minus 8 is equal to 0. Now you will do I minus minus. Okay. Now I minus minus, that means your I is 11, right? Your I is here. Now is 11 greater than 8? Yes, it is. So you're going to remove this. You will replace this with 11. Now what will be your maximum value? It will still remain the same because 11 minus 11 will still be 0. Alright. Now what will you do? You will move one step ahead. You will come here. Now is minus 7 greater than 11? No, it's not. So your largest is still 11. What will be your difference? It will be 11 minus of minus 7. Alright. Which will be equal to positive 18. Right. Now your previous one was 0. Your max difference was 0. Right now it's 18. Which is better? 18 is better. So we'll keep the max difference as 18. Okay. Now moving ahead. The next one. So what will happen to your I? Your I will get decremented again. Now is 6 better than 11 being in terms of being largest? No. So we'll still stick to 11. Now 11 minus 5 is equal to 6. So is 6 better or 18 better? 18 is better definitely. So we'll stick to 18. Get rid of this. Alright. Now again decrement it. 1. So is 1 better or 11 better in terms of largest? 11 is better. We'll stick to 11. Now 11 minus 1 is 10. Now in terms of maximum, which is better? 10 or 18? 18 again. So we won't do anything to our max. Alright. Now we'll get it decremented again. So this will be minus 5. So is minus 5 better or 11 better? 11 better definitely in terms of largest. So we'll do this. What will be the value? It will be 11 plus 5, which will be 16. So is 16 better or 18 better? Definitely 18 is better. So we'll keep 18 as the max difference. Now, last element, we'll decrement this. Is minus 3 better or 11 better? 11 better. So we are sticking to the 11. Now 11 minus of minus 3. What will be the value? 14. Now is 14 better or 18 better? Definitely 18 is better, right? So what are we at? The max value is 18 and your output is also 18, right? So you got the right thing. With what pair? 11 minus minus 7 that gave you 18. All right. So why did we avoid sorting it first? Because it's not an optimal way of doing it. Okay. Here you see just using a loop in backward direction or reverse direction, we can arrive at this particular juncture. Okay. And just one loop. So your time complexity will be big O of n. And honestly, we didn't store anything. So your space complexity will be a constant. All right. Now let's go back to our collab and let's code that. Now this will depend on two things. Okay. How the, it will basically have two different way of writing it, but uh, it's the same code. Okay. Why two different way of writing it? Because it depends on how the user input is being taken. So for that, you have to refer to the question. Okay. So suppose we have solve. All right. And we do ARR, we pass the array and then we take a value called largest and then we take a value called max difference. Okay, we do this and we assign it to what will be the initial value? It will be float of minus infinity and also the other one will also be minus infinity. Okay, both will have minus infinity. Sorry about the quotes. Yeah. Now we'll run a for loop with I, but this will be in the opposite direction in the range. What will be the range? It will be length of ARR minus 1. Alright. And it will go all the way till the end of the loop. Okay, now we'll assign a value num which is equal to your integer at arr of I. Okay, once this is done, we'll have largest is equal to max of either the largest or the num. Simple, right? Once this is done, what will we calculate? We'll calculate our max difference, which is equal to the max of max difference, comma, definitely the largest minus the num. Okay, whichever one it is. So last, what will we do? We will just return max diff. Okay, that's it. Now, once we have done this, we have to take the input, right? We'll take def input, say array format, and this is the array format. It shows a proper bracket and everything. So if that is the array format, then your input will look something like this, a list. Then we'll have a map, and then we'll make it a string. So it's easy to concatenate, and we'll do strip, or yeah, strip is better. How do we strip? We strip it wherever there is a bracket like this, okay? And once that is done, what will we do? We'll split. We'll split what? We'll split it by the comma, okay? We'll split it by the comma. Once this is done, go for printing it. So print, and say we do, let's consider to be case 1, okay? And we'll take the input as whatever it was. I don't remember. I'm just guessing it was this 1, then 6, then -7, I guess, then 8, then 11. Okay. And then what are we going to do? We'll do comma max diff, right? We'll do max diff. That's it. And what function will we call? We'll call solve AR. Okay. Once this is done, how are we going to call for the function? We are going to just call input array format, and that's it. Okay. Suppose we will just enter this same thing. Okay. So that's it. And there's another way in which you can do, that is definitely up to you if you want to really change how the things work. All right. So this is exactly what you are going to do in the whole code. And I guess you now understood that how this can be done. Well, I will see you in the next video. Until then. So it says that a person has many shoes of different sizes and he wants to arrange them. You need to calculate the number of pairs of shoes he has. Okay. So now it says your input number is 8. Okay. It is 8. But how many pairs do you have? 1, 2, 3, 4, 5, 6, 7, 8. But how many actual pairs are there? So for every left leg, there will be a right leg, right? You cannot have, this is the valid combination, right? You cannot have R, R. You cannot have L, L, right? It has to be LR. So there is a 7L, there's a 7R. So this is a pair. Now there isn't 7L here, there's a 7R here. So these two are a pair. Now there's an 8L over here and there's a 8R over here, right? So these two are a pair. And this is a 6R, 6R. So this is not a pair. So how many total pairs you got? You got 1, 2, and 3. So your output is 3. Similarly, here you have L and R. So this is 1, right? Here you have L and R. So this is 2. So there are 2. Okay. And this is just a single. You just can't wear a shoe in just one, right? So the question is asking that number of pairs. So pairs means always you have left and right. All right. So what will be the best way to use it? Use a map. As simple as that. That means if you have 7L, you map it to the number of occurrence. This is your key. And here you will put the value. How many 7L do you see here? Initially 1. Okay. Now you iter over 7R, right? How many? 1. Then 7L. You don't create a new key. Rather, you just update this one, right, to 2. Similarly, 8L, there is no 8L mapped yet, so we'll put it up as 1. Then 6R, 6R also as 1. Then 7R, we have a 7R, so we are not going to create another one. We'll just increment the number, okay? Then we have 8R, we don't have 8R over here, so we'll put 8R. Then we have 6R. Now we have 6R already, so we are going to just increment this to this. Now what will we check? We will check that if there is a number called 7L, then, and it has two pairs, then it should have 7R, at least one to make it a pair, right? So that means if we are going to look into this map, we will check that do we have 7L? Yes. Do we have 7R? Yes. Then we are going to take the minimum number of these values, and that will be the number of pair for 7L and 7R. Here you have 2 each, so there will be 2 pairs. Okay. In 8L and 8R, you have 1 each, so it will be 1. And in 6R, there is no 6L, so it won't be a pair, right? So it will be 2 plus 3, that will be 3. All right. And this mapping definitely will happen in time complexity of big O of n. And what will be your space complexity? That will also be big O of n, because for time complexity, we are using a loop to traverse over this given array, okay, or the list. And that is why it will be big O of n, because we are going to use a for loop. And for space complexity, definitely it will be big O of n, because we are using a map to store it. All right. So let's just go and try to code this. So let's take a number n, which is equal to, say, int, and we'll take the input of how many elements do we want. Like here we have it to be 8, right? So this 8, we'll be taking it as an input. Then say we'll take input as list L. How will you take this list L input? Definitely use the list command, right? Use list and then do map. We'll put n string over there because we are having 7L, okay? And then we'll do input. And what are we going to do? We are going to split it, okay? Because we are going to compare the L and R only, okay? Then we'll have something called as the store, okay? Where you're going to see the number of collection, which will be a dictionary or a map, okay? Now, for what? For the shoe size, okay, which is equal, for shoe size in where? In the list L, okay? What are you going to do? You're going to do if the shoe size is in your store. It's already there. You have added it to the map. Okay. Then what will you do? You will just increment that value, right? You're just going to increment that store. In the store, you will just increment the value. Like in the map I just showed you, right? You're going to do that. Increment the value by 1. Okay. If that is not the case, what will you do? You will do else and you will append it. You will append that store shoe size to the map by 1. All right. You're going to do this. Now let's take a value called pairs and set it to 0. Okay. Now for your key comma value pair, right, in store dot items, this is exactly how you iter over the key value pair in your dictionary. All right. So you're going to do this. So what will you get then? You will do if your key -1 starting with the last character, so that was equal to your L, okay, capital L. If that is the case, then what will you do? You will do your value is equal to your key of up till that number, okay, and then what is it? It is plus R, okay. You're going to look for this, okay. And if your val in store, okay, if your val in store is there in store, then what will you do in your pairs? You will just increment the pairs, okay, by what? You're going to find the minimum, okay. That is exactly what we spoke about. We are going to find the minimum of key, and if it's in the key, whether the key is the small value or the val, okay. So whether it's in the key or it's in the value, we are going to find the minimum number of things, and then we'll run for the else part. What will be the else part? Definitely the other half, that is for the right side. Now, whatever comes first, if you come across this first or that first, that's completely up to you. If you're going to do that, we'll do all the way till that -1, and then you're going to do it for L, okay? Because here you are checking it in the right pair. Okay, once that is done, you will do if val in store. Okay, if your val is in store, then let me just copy this. Okay, if val is in store, we are going to do the same thing. I'm just gonna paste this, and you will have pairs. Sorry, you will have, actually you're going to print this. So print what? You're going to print pairs, and you are going to take the integer division. You don't want your answer to be in decimal, right? So that is all that you need to do. Okay, so if I remembered the order correctly, very good, we'll get the exact answer. If not, whatever I enter. So if, say, I entered 7L, then 7R, then I enter 7L, then 8L, then 6R, then we have 7R, then we have 8R, and finally we have 6R. Okay, so yeah, it's giving us the output as 3. All right, so that is all that you need to know, and definitely not to forget, your time complexity is equal to big O of n, and your space complexity is equal to big O of n, right? So this is your time complexity and space complexity. I hope you have understood this question. It wasn't that complicated. And why did we take integer division? Because what if it comes down to 2.5, 2.4? It won't. According to the calculation, it won't, because we are not using the division thing. But if in case it comes down, okay, just to avoid any kind of risk, it's advisable that you always take the division thing, okay, integer division. All right. So if you look into the question, it says that in the company there are employees, which is obvious, whose efficiency is given in the array ARR, and it can be negative, right? So find the maximum efficiency of 3 employees. The efficiency of the employees will be calculated by multiplying their individual efficiency from the given array, right? So what will you do? Very simple. First, you have to sort this. Okay, once sorting is done, what will you compare? You'll first find, like, if I sort this, it will be -2, -8, 1, 3, and 4, right? Now, once this is done, what will be the value? It will be n minus 1, this will be n minus 2, this will be n minus 3, this will be 0, 1, right? So no matter how big the array keeps on going, if there were numbers, oh, I'm sorry, I just wrote a wrong increment order, I didn't notice. So this will be just the opposite, I'm sorry. So if there were more numbers in between -2 and 1, or here, no matter what, okay, so your top 3, if they are all positive, will be the last 3 elements from the array, right? And if they are negative and that is the highest, it will be the first 3 elements, right? So it will always be either ARR of 0, ARR of 1, and ARR of n minus 1. Or it will always be ARR of n minus 1, ARR of n minus 2, ARR of n minus 3. Okay, because this is sorted, anyone, either the multiplication of 2 negatives will result higher than multiplication of, sorry, yeah, 3 positives, whatever it can be the case. Okay, so whatever is the correct, we have to take max of either this or max of this. So this is step 1, sort. Step 2 is just multiply and see. All right, very simple to code. So first we'll take the input, that is n, which is equal to say int, why is all capital, so int input, we'll do this, and then we'll create an array ARR where we are taking the input just to see. So we'll do that as list, then map, and we'll do that as int again, and it will store the input. And what are the first steps? Definitely sort, ARR dot sort. Now if this is the max value, okay, and all are positive, it will be the last element, right? So it will be n minus 1. What will be your employee 2 then? Your employee 2 will be ARR of n minus 2, right? And your employee 3 will be equal to ARR of n minus 3, correct? Right? Now, there is another case. What if there are negative values and there are two negative values? Only two. Why? Because negative into negative will make it positive. But if there are three negative values, then it won't be positive. It will be negative, which will be less. So remember that condition and say negative 2 is equal to ARR of 1. Definitely, right? Because if those two are negative, then only it will make a positive value, which will be higher than the positive, if in case. Okay. Now, what are you going to do? You're going to take the max. You are going to take the max of EMP 1, 2, and 3 if they are all whatever the value is. Otherwise, you will take max of EMP 1, negative 1, and negative 2. Okay, and you will calculate the max. Okay, there's a comma. Don't miss out on this. I'm not multiplying everything. Okay. So once this is done, it is going to return you whatever the max is, whether the multiplication of last three elements or the multiplication of the elements when there are negatives, right? So if we just enter the same, say this, and we have, I guess, 3 minus 2, then minus 8, then 4, then 1. Did I give a space here? Oh, yeah. So it's giving you the result 64, right? That was our output. Now, what is the time complexity of this? Now, the time complexity will definitely be big O of n log n. Why? Because we have a sorting technique which uses log n and n elements, so n log, right? And for space, it's very simple. It's just a constant because we're actually not storing anything. We're just simply printing it, right? So it's just going to be constant, big O of 1. All right. I hope this video was helpful and you guys understood. It was a pretty simple, easygoing question. You don't have any loops, nothing. Just sort it and little bit of common sense, right? It says that you're given an array called nums of size n. You have to return the majority element. So what is a majority element? The element that appears more than, I would say, n by 3 times. That means at least 3 times it has to occur in that, right? So, and you assume that a majority element always exists. So, n by 3 means what? Suppose there's this element 3, right? I'm going to see how many times is this occurring. 3 by 3 times, right? So, 3 by 3 will be 1. So, basically, any number repeated more than 1 or equal to 1 is the answer. Okay? So, if what do I mean by greater than or equal to 1, more than 1 or equal to 1 means the number of times. Okay, if their division is equal to 1, so a number has to occur at least 3 times, at least 3 times to satisfy this n by 3 condition. Okay, because you're dividing it by 3, right? So at least it has to be 1. And how will it be 1? Only when it's there as 3 or more than 3. Got it? So like here you have 1 by 3 which is going to be less than 1, right? So this is not a your majority element, but 3 is there how many times? 3 times, which is equal to 1. So if it is greater than equal to 1, that means you can always choose that number. And it says that the majority element always exists. Okay? So if we see the first input, how many elements do we have? We have basically two elements, right? 2 and 3. So how many times 3 is occurring? 3 times. So your n is 3 by 3, which is 1. Then 2, how many times is it occurring? 1 time. So what is your n by 3? It is 1 by 3, which is equal to something. Okay, that is less than 1. Similarly, what will be your output then? Your output will be any number that appears more than or equal. Sorry, this should be more than equal to. Okay. So we are going to consider which number? 3. So here the output was 3. Right? Now, over here if you see 1, 2, 3, 4, 5, 6. So 6 times 2 has occurred and it is 6 by 3 which is equal to 2. Right? And 1 has occurred 2 times, so it will be 2 by 3 which is less than 1. And 0 has occurred 1 time, it will be 1 by 3 which is also less than 1. So what will be your output? 2. So your output is 2, right? Now with brute force, what will you do? You will basically iter over the loop and keep counter for every number, may that be 2 or 3, right? You'll keep an counter and you keep iterating and then finally do this, right? But if you use an optimal method, what can you do? You can actually have a map which will have the key value pair, right? So that means you can just store your key as 3 and how many times it has occurred as the value, right? And whatever has, and then do the n by 3 operation on each. Okay. And whatever value will be greater than equal to 1, you're going to print that key. Okay, not the value, you'll print the key. Got it? So now let's just go to Colab and try coding this. Shouldn't be difficult, but let's give it a shot, right? So if we say that we are going to find majority element, we have to find this. We'll pass ARR, comma, N. Okay. Now, once we do this, we are going to have a map or a dictionary called frequency. And what will we do? We'll run that for N in ARR, right? Because that's the array that we have chosen. And then you will assign your num is equal to int N. Okay, that is basically going to keep the counter. What are you trying to do now? You are trying to do if your num is in the frequency, if it's already there in the map, then you will just simply increment that number by 1. Okay, you just increment that number by 1. Else what will you do? Else you will just append it. That means you will just do frequency of that number and set it to 1. Okay, that's all that you need to do. Now you will run, you will go for this iteration, but how will you do this? Did I just miss on something? Yeah, so you will do this for key, comma, val, okay, in frequency dot item. All right, this is how you are going to fetch it. So if this is going to iter over the map, you will compare whether the val is greater than equal to what? N integer division. Never do normal division. Integer division, because you just need the integer value. Okay. Then what will you do? You will print key and the end. Okay. All right. That's it. That's all that you have to do. Finally, we'll run an input. Okay. And say array format. Now, what are you going to print? You are going to print, you just to so that you know what your data entry point or the input user input should look like. I'll just put in a hint. So it will look like something like this. Okay. You are supposed to do E1, comma, E2, comma, E3 like this. Okay. And now you will take the input ARR is equal to your list. You will put the map. Now it's a string input. Okay. So it has to be string this. Okay. So what did I do? I took a string input. I stripped it from where? From wherever my bracket will start, and I'm splitting it after every comma. All right. And what am I going to call? I'm going to call find, what was the function name? Majority this. Okay. Now once this is done, we will connect our collab first. All right. And we'll run this. So once you run this, you are going to basically take an input. Now what is this input going to be called as? This is going to be called as the input. What is the function that we have right here? We have input format, right? Array format, and we'll call this function and now run this. Okay, so this is going to be how you enter it. So let's just put this into the bracket, that is 3 comma 2 comma 3 comma 3. All right, I guess this is it. Yep, let's hit enter. So it actually gave you the result. Okay, it printed the key and it also printed the end. All right, so I hope that you've understood, and this is all that you needed to know. I will see you in the next video. Until then, keep learning. And yeah, before I leave, just so that you know what will be the time complexity of this. Definitely you're just using one for loop. Okay, so it will just be big O of n. Okay, it will be big O of n. All right. Okay. It says that given an array nums with n objects colored red, white, or blue, sort them in place. Now again, in place means you're not going to use another array. You are going to just use that array to operate and execute, do whatever you want to do. Okay. So that the objects of same color are adjacent with the color in order red, white, and blue. We will use integer 3, 6, and 7 to represent the colors red, white, and blue respectively. Okay. Do not use the inbuilt sort function. Okay. So now the input has been given as 3, 6, 3, 7, 6, 3, 3, 3, 7. So it has to be 3, 3, 3, 6, 6, 7, 7. Right? That has to be your output. Now, how are you going to go about this? First thing, definitely brute force. Okay? Uh, brute force. Now, in brute force, what will you do? You will run a loop for 3, right? And you'll keep counting it, have a counter, and that will keep incrementing. Similarly, run a loop for 6, keep a counter, keep incrementing it. Similarly, for 7, keep a counter, keep incrementing it. Okay. Now, note one thing that we are not given the value of n. We don't know. Okay. Second, this is a string input. This is a string input. This is not an integer. It is string. Okay. Now, once you have the count, you will know the number of n's, right? How many number of 3s are there, 6 are there, and 7 are there. Now you know the count, right? So then you can create an array and add them, okay? By comparing which one is smaller or greater. So what will be your time complexity here? Your time complexity will be big O of n, and your space complexity will also be big O of n, okay? Now, but this is brute force. It is not the optimal method, right? You definitely need to figure out an optimal method, okay? If you see the output 3, 3, 3, 6, 6, 7, 7, right? Can I divide this output into 3 parts? This as the left, this as the mid or middle, and this as the right. Can I do this? I can, right? So now we are talking about the optimal approach, how I can do it, right? What will I do? I will initially assign my left to this and my m also to the 0th index. Okay? And I'm going to do a comparison that if my ARR of mid is equal to 3, then what am I going to do? I'm going to swap my left and my mid. Okay? Then I will increment my left and increment my mid. Now the first element is 3. It is a match. So what will it do? It is going to swap it. Okay? Now in swap, nothing will change because both are pointing to the same index. Correct? Now you have to do mid plus plus. Now mid plus plus, your m is here, right? And L plus plus, your L is also here. Correct? Because this L is filled, right? It is completed. So we don't need this anymore. Now again this is true. So again it is going to swap, but no point. Oh, sorry, I'm probably working on a sorted array. Let me write down the actual one. I'm sorry about that. So the actual one is we'll get rid of this M for now and this L. Okay. So the unsorted one is this. Okay. Now my L and M are both pointing to this. So this first condition is satisfied. So if you swap it, doesn't matter. So you're just going to increment M. You're going to increment L. Now your M is 6. So you'll have another condition when ARR mid is equal to 6. At that time, what will you do? You will swap your left and your mid, but only increment the mid. Okay, why? Let's see. So your L is also 6, your mid is also 6. You're right. It's saying that these two are 6, right? So now once you do this, what will happen to your thing? Your mid and your L. Your L is over here, right? Your L is over here. Your mid is also here, right? So if you swap, nothing is going to happen, right? Your L will still be pointing to this and your M will be incremented to this. Correct? Now, once you do this, now you'll see that ARR of mid is equal to 3. Now if you swap, now if you go for a swap, what will happen? 6 will come here and 3 will come here, correct? So your array will look something like this. Your 3 will come here, your 6 will come here, your mid is pointing here, your L is pointing here. Okay. Now after this step, then you will do left plus plus. Okay. Now you are here, and again mid plus plus, you are here, right? Now it is going to check that, okay, your M is equal to 7. So you will definitely have another condition. We are going to get rid of the brute force. Okay. So you will have another condition calling it ARR of mid is equal to 7. If that's the case, then you swap the right and the mid and do what? Right minus minus. Okay. So now your M is 7 and your R is here. So what will you do? You will interchange them, but won't make any difference because it's going to look the same, right? Because both of them are 7. So where is your M? Your L is here, your M is still here, your R is here. Okay, because we are not doing anything to the mid, we are just decrementing the R. So after that swap, where will your R be? Your R will be here, right? In this location. Now once the R is here, what will happen? It will again check that 7 is this one, right? So again, what will it do? It will swap these two. Okay. So after swapping, what will be the value? This will become 7, this will become 3. So this will be your 7, this will be your 3. Okay. Now what will you do? R minus minus. Your M is still here. Okay. Now your R is just below 6. Now M is a 3, right? Now 3 is here. So what will you do? You will swap these two, right? And what will be the value? It will become 3 and this will be 6. And what will you do? You will increment L and you will increment M, right? Your M will be here and your R will also point to the same thing, correct? Now, over here, you will just return. Why? Whenever your mid becomes equal to your right, that is when you stop the execution because you're done with it. Okay, just stop the execution and exit the loop, right? Let's see how we can code this. Okay, so suppose say we have def sort by swap, maybe that is something we can name it. We'll send arr comma say n. Okay, now we'll have left which will be equal to 0. We will have mid initialized to 0. We'll have right initialized to 0. Actually not 0, n minus 1 because that's the last most, right? Now what will you do? You will do while your mid is less than equal to right. This is your main looping condition. The moment it hits this condition, you're going to exit. So if that's the case, you will do if ARR of mid is equal to what's the first case? It's 3, right? This is case 1. Then what will you do? Your ARR of left, okay, and your ARR of mid, okay, this will be equal to what? It will just swap each other, right? That will be ARR of mid, comma, ARR of left. Got it? Now what will you increment? You will increment your left by 1 and your mid by 1. Okay? Now, else if, what is the other condition? Else if your ARR of mid is equal to 6. If that's the second condition, then you will just increment the mid, okay, by 1. You're not doing anything to the left or the right. The next one will be if your ARR of mid, what is the last condition? It's the 7, right? It's for, guess, the blue color, 7. Then what will you do? You will have ARR of right. Okay, ARR of right, comma, ARR of mid. What will this be doing? This will again be swapped with each other. It will become ARR of mid, comma, ARR of right. Correct? And finally, you will just decrement right. You're not doing anything to the mid. Okay. Once this is done, what will you return? You will return ARR. Okay. Now, finally, you will just do the print. Okay, I will just mention this thing for you guys to understand better. So the input basically will be taken as space separated. Okay, so ARR is equal to, how will you write? It will be a list, definitely. What will be the type? It will be a string input. Okay, we have spoken about this earlier in the video. And you're simply going to split it from where? From the space. Okay, and finally we'll call the print function, and we will call our method sort by swap, and we will do ARR comma length of ARR. All right, so if we run this, and what was the input? Let's think. Yeah, I guess it was 3 6 3 7. I'm just randomly entering it if this is what it matches with, right? So you see it sorted it to 3 3 3 6 6 7 7. All right, so I hope that you have understood this and this video was helpful. You can solve such questions. Yeah, again, talking about the final thing is definitely the time complexity. It's going to be big O of n. There won't be any difference in the time complexity of brute force and space complexity of brute force with the optimal. There's absolutely no difference, but it's a better way, better method, not that complicated, not many for loops being used for iterating. Okay, just an if else condition and one while loop. Okay, so it's a pretty straightforward and simple question that's been asked by TCS. So it simply says that you're given an integer, okay, and that integer can be anything. You have to find the sum of values of that table, okay, such that if your input is 10, it is going to do 10 into 1, 10 into 2, 3, 4, all the way till 10 into 10, and then you're going to do a sum of all of them, okay. So does this mean that if I have the value 11, then it must go on to 11 star 1 all the way till 11 times 11? Then your answer is yes. This is exactly what it means. Okay. Whatever the value entered is, you are going to find the sum of that particular table. Basically, you're finding the summation of all the multiplication number all the way till that number. Okay. So if it's 155, then you are going to start with this 155 into 2 and go all the way till 155 times 155, right? This is the thing. But you can solve this in a very easy way. It's not that complicated, not at all. So let's get coding. So we'll take an input in integer format, definitely. Okay. Once that's done, take a variable called multiplier sum. Okay. And now we'll run a loop I in the range 1. It will start with 1. We are not starting the multiplication with 0. We are starting the multiplication with 1. And it is going to go all the way till n plus 1. Why did I take n plus 1? Because if my n is 10, then I don't want to exclude 10. Okay. I want to include it. So I'll go all the way till 11. So 11 is excluded, and it's going to take it from 10 ones are all the way till 10 tens are, right? So now what will we do? We'll do a multiplication sum. We are going to do the sum, but at the cost of what? At the cost of the multiplication table, right? This multiplication is important. We need to do the multiplication and then the sum, correct? So we'll print the m sum or the multiplier sum, and say we take the input as 10. It's going to return us 550. All right, so it's that simple. So if you calculate the time complexity, what is the time complexity? It is big O of n, right? Because just one for loop iterating for n times whatever your n, your input is. And what's your space complexity? That is going to be a constant, because technically you are not taking in any kind of space, right? There is no memory consumption. You are just simply running an m sum and you're returning it. That's it. Okay. But if you look deeper into the question, what was the trick then? The trick was this condition, running the loop correctly. If you miss out on the loop, you're going to miss out a lot of things, right? So I hope this video was helpful. You understood. It was pretty simple, easy, but yeah, it was asked in TCS. This is not difficult, but you need to understand how to exactly solve it. So it says that given an array and an integer k, you need to find the maximum element. I mean the highest element in each of the continuous subarrays. Okay. So basically, you are given an array. Okay. So you are given an array, like the one that's given here. So it says it's 2, 4, 7, 1, 6, 3. Okay. So every time when, say, suppose I is equal to 0, okay, we don't know anything, we're just doing the dry run, okay, and your k is given as 3, that means only 3 elements will be there at every iteration. Now, amongst these 3 elements, what is the maximum? It is 7, right? So you see the output 7 here. Now the window shifts, right? It shifts to the next. These 3 are the continuous. Here I is equal to 1, correct? M is again 3. So what is the max here? Max is again 7. So you see 7, correct? Now 2, 2, 4, 7, 1, 6, 3. It will shift again, right? Your I is equal to 2. What's the max? Max is 7 again. So you see 7. And finally, it will shift again to this. What is your max? It is 6. 6. Next, it cannot shift because this will go out of bound, right? So, how do you know what will be your value of I? How do you know what will be your range of I? It will basically be n minus k. Okay. What does that mean? That means it will, what is your n? How many elements are given? 1, 2, 3, 4, 5, 6. 6. And what is your k? 3. So your I will run all the way from 0 to 3. So if you see 0, 1, 2, 3. Got it? So this is your formula. Okay. But this is what? This is brute force. Okay. What will be your time complexity? As you can see, you will run 2 loops, right? I and j simultaneously. Why? Because one loop will keep a track that there are 3 numbers. The other loop will calculate the maximum. How will it calculate the maximum? It's going to keep iterating over all the 3. So it will be big O of n square, right? And your space complexity will be big O of n or big O of 1. This is debatable because we are actually asked to take an input and we are returning the same array, like whatever it is. So it is debatable, but most of them will consider big O of n. So I would request you to consider big O of n. But now let's see how do we actually code this, right? So as you know, we'll have to solve, right? When we solve this, we'll have to basically define a function. So let's define, just name it solve. And we'll take the array input and the k, and then we'll take the answer as a empty list. Okay, perfect. Now for I in your range, what will be the range? It will be the length of ARR, that is our n, minus k. And then what will we do? Plus 1. Why plus 1? Because if we just do it till n minus k, that is the formula, correct? It has to go all the way from 0 to n minus k, right? And if we stop our range at n minus k, that means our last iteration will be eliminated. So we need to go one step further. We need to add it, okay? We need to make that n minus k inclusive. Oops, I'm so sorry. I pressed the wrong key. We need to make that inclusive, okay? So now we need to say consider the max element and we'll put it as max of I will be equal to ARR of I, right? Now we'll run another loop j. Now j will run from range of 1 all the way till I plus k, correct? Now what will be your max I? Your max I will basically be either the max of max I or ARR of j. Okay, either one, whatever the max value is. Okay. Once this is done, what will we do? We'll just do ans or answer dot append the max I. Okay. Once this is done, we are finally going to print the answer. Correct? All right. Now, once this is done, we'll go back here. We'll execute that little later. First, let's understand the optimal method. Okay. So this is a brute force method where we are using 2 loops. What would be our optimal method? What would be our optimal way of doing this? We'll use something called as the heap. Okay, we have already covered this in our DSA course, which is called the priority. I made a spelling mistake. Priority queue, also known as the max heap. Or in Python, we don't have anything as max heap. We use min heap, which is already inbuilt, and do a negation of that. That will basically be the max. Okay. So what will we do? Basically, we are going to, I will write down, but first let me make some space. All right. So we have this given array, which is 2, 4, 7, 1, 6, and 3, right? So this is 0, 1, 2, 3, 4, and 5, right? So we know that our I will travel from n minus k, so which is 0 to 3, correct? So when I is equal to 0, so at that particular point, okay, all the way till 3, what will happen? First thing first, okay, this window will be considered. So which one is the maximum here? 7. So which one will become the minimum? 7. How will you write that? Minus 7 comma 2. What is 2? Index. Okay. Then what will be the next one? Minus 4 comma 1. Then minus 2 comma 0. Correct? Next, what will you do? It will shift from here to here, right? So what will it have? It will have minus 7 comma 2. It will have minus 4 comma 1. It will have minus 2 comma 0. It will have minus 1 comma 3. Okay. Now next, what will happen? It will again shift minus 7 comma 2, minus 4 comma 1, minus 2 comma 0, and finally, oh, I guess I missed minus 6. So we have 6 here. Yeah, I'm going to rewrite this again. So it will be minus 6 comma 4, minus 4 comma 1, minus 2 comma 0, and minus 1 comma 3. Correct? Now, you must be wondering that, okay, I just spoke that k is equal to 3. This here is correct. What happened here and here, right? Point, right? So how are we calculating the k value here? So basically you have to see that this at this point, right? What is your iteration value? Your I is equal to 4. You have 4 elements, right? I is equal to 4. So what will you do? You will do 4 minus 2, right? Which is equal to 2. Correct? So by the time it is less than equal to 3, this number, this is valid. Okay. Similarly, in this case, if you see, sorry, not in this case, the next case that will come across over here. So next one, your window will shift to this. So it will be minus 7 comma 2. It will be minus 6 comma 4. It will be minus 4 comma 1. Then it will be minus 3 comma 5. Then minus 2 comma 0. Then it will be minus 1 comma 3. Right? In this step, if you see, what is your I value? Your I value is 5. Right? Your I value is 5. Your I is here. So, what is your index of this one? It is 2. So, 5 minus 2 is equal to 3. Correct? Now, 2 is not less than equal to 3, right? It is, sorry, not, yeah, 2 is less than equal to 3, right? It is less than. So, what will happen? You are going to pop this element out, and this will be your first element inserted into your heap. Okay? So, it will be 7. Okay, before this, I forgot, we'll have to pop it here, here, and here. So, you already have 3 sevens here. And this one will be your last 7 that will come in, and after this will be your 6, right? Now, in order to execute this whole heap, we have to use a function called as the import heap q. Okay, so we will write import heap q here. Okay, and let's continue solving. So suppose I'll do optimal solution. Okay, and we will pass arr comma k. Correct? We'll do this and we'll initialize two things. One is an empty heap. Other is the answer solution. Now, for I in range of, what will be the range here? It will be k, definitely. Okay. So what are we going to do? We are going to do heap q dot heap push. Okay, we'll do heap push. And what are we going to push? We are going to push into the heap two things. First is the negation of arr of I. Next is just the I. Okay, the index, the element and the index. Okay, what will we do then? We'll append this answer. But what are we appending? We are appending the negation of the heap value again, okay, because we need the maximum, right? First we bought the maximum, made it negative, and again from negative we have to convert it to positive because we need to return the max value. So it will be at 0 0. Okay, once this is done, we'll run for I in range k comma length of ARR, whatever the length of ARR will be. Okay, once that is done, we'll again do heap q. Now we are doing heap push again. Okay, and again we are going to repeat the same thing, that will be heap comma minus of ARR, that is I, and also I, right, the index as well. Now once this is done, now while your heap of 0 1 is less than equal to I minus k, okay, this, when this condition arises, okay, what will you do? You will pop the element. Okay, heap q will be heap pop. I guess I made a spelling mistake. Yeah, heap pop. And what are you going to pop from? You're going to pop from the heap, right? Definitely, that's the only thing that you have. Now what will you do? That whatever you have popped, you're going to append it back into the answered queue. But how? Again, taking the negation. Why do you need to take the negation? Because you had made it a negative number, right? Now finally what will you do? You will print your answer, right? Once this is done, we'll do ARR is equal to, now we are taking the input. We know how to take input, right? So we are going to do input, no statement to be passed, simply take the input function and split the values, right? That's it. You need to take k also as an input. So we need to take k. And once this is done, now we have two functions, right? One is solve ARR comma k, and the other one is optimal solution to k. All right. All right. So yeah, we'll look into the time complexity a little later. Let's first look for the brute force. Okay. Let's run this. So what should be our value? I guess this is the number 247163. Then k will be 3 and it's returning 7777. Ooh, okay. Guess we made a small mistake somewhere for which it's returning 7777. So should be, so I plus k return. Okay, let's execute the other one and just check, as that's a brute force one. Let's execute the other one. So if we put 247163 and then do a 3, oh, okay, that's correct. The heap one is correct. So maybe there's something small error somewhere. I'm not able to see it right now. But anyways, we do know what the time complexity for this one would be. It would be big O of n square. Why did I execute this again? All right, I will run this once more. 247163, and yeah, you have it there. Okay. All right. So what is your space complexity for brute force? We spoke about this. This is definitely big O of n. You can consider one, but most of them will consider it to be big O of n. Now, considering the time complexity here, what will be your time complexity? It will be n log k. Okay, n elements and log k, because we are going to use the heap to sort all of that together. So if you have not seen the heap video, which is there in the data structure course, highly recommend watching that, so you know how heaps are actually implemented. It's not that complicated. But yeah, when it comes to question solving, we panic because we don't know the idea of heap. So that's the whole purpose. So here the space complexity is going to say same as the brute force, but your heap time complexity will change drastically. So from n square, you can bring it down to n log k. All right, log k because of the heap q that we are using, and n because n elements. All right. So this one is pretty simple. It says calculate the sum of nth term in the Fibonacci series. So where your base cases are given, that is 0 and 1. So if I take my input to be 5, usually how does your Fibonacci series look like? It's the summation of the previous two, right? Correct? So it should go on like this: 0, 1, 2, 3, 4, and 5, right? But how is the output 7 then? So what it is doing, it's basically summing up the previous values. So 0 plus 1 will be 1. This is 1 and 0. These are the base cases. Okay, so 1 and 1 will be 2. Now, it is going to sum all the way till here. So this will be 4. And again till here, this will be. It's not considering this one. It is considering itself and the previous two. Okay, so the value will be 7. So if your n is 5, your answer is 7. So how do we go about coding this? I know it's a little confusing, but you need to just think about the logic that why is it 7 when it should actually be 5, right? So let's define, say, Fibonacci, and we pass what? We'll pass n, right? Obviously, because that is what we need. Next, we will do a previous n minus 2, and let's call that priv 2, comma. We'll do priv, which will be equal to 1, which will be the n minus 1. So the values will be 0 and 1 respectively. Now, if we do n is your equal to 0, then what are you going to do? You're going to return priv 2, right? The first base case. Else, if your n is equal to 1, then you will return your priv, correct? That should be your answer. Now, we are going to take a sum, say fib sum, and set it to 1. Remember, this should not be 0. Okay, it should always start with 1 because we are not in the 0th index anymore. So this range will start from where? This range should technically start from 2 all the way till n. Why 2? Because if you go back, we are calculating this one. We are already given the base cases, so we are not bothered about this part. We need to start from 2, correct? All the way till n. And once this is done, what will we do? We'll do cur is equal to, your current will basically be your previous 2 plus your previous, right? That is exactly how Fibonacci series is solved. So what will be your fib sum then? Your fib sum will be equal to your cur. Okay. You can then print. This is just for you. Do not do this in the final exam. Okay, this is just for you to understand whatever the steps are. So we are going to print each and every fib sum. And finally, you're just going to change your priv 2 and your priv, which will basically be incremented to the next one. So it will become your priv and your cur respectively. Okay, so your priv 2 will become your priv and your priv will become your current, right? Once this is done, what will you return? You will return your fib sum, correct? Now, outside the function, you're just going to do an int input. Do not take anything into the input format. And then finally, you're going to print the Fibonacci. And what will you pass? You'll pass n, right? So if we run this and hit enter, you see the output is 7, right? What is the time complexity of this code? The time complexity of this code is n, while the space complexity is a constant. Okay, so there are much better ways in which we can do Fibonacci series, and we'll come across those in the data structure Python with Python course. So I've already done a video on how to solve Fibonacci series using recursion. What can be a better way if we actually use dynamic programming on recursion, which is much simpler and easier to do if you understand it once. Okay, there won't be any kind of recursion. You can basically use a bottom up approach, okay, and optimize it. Well, this is a one way in which you can solve it, but there are multiple other optimal ways which have been solved in data structure course. It says that in a database there are n students. The fields of the tables are name, age, grade, and gender. Return the student name whose age is greater than 20, and calculate the average of grades using ASCII value of the female students, right? So basically two things. One, you have to check whether age is greater than 20, and what are you returning? All the names. Next, what you're doing, you're checking if your gender is equal to female. Then what you're doing, you're calculating the average grade. But how? You're first converting the grade to ASCII, right? So these are the two things. What you need to consider here is how you take the input. Now, input cannot be taken simply as int input, right? Why? Because the input is in one single line, everything entered together, right? You see. So what will you have to do? You will have to take the input in single line. So how do we code this, right? So we'll start by taking two things. One will be the grade total. The other will be your, say, total female. Okay, and we'll set both of these variables to 0 and 0. Okay, now the answer should return an list of your names, right, whose age is greater than 20. So we'll run a for loop in the range. What will be the range? Whatever number you input. Okay, so we are going to put this as int input. So yeah, what's the issue? Yeah, there should be another dot. Yeah, I was just doing that. Yeah. All right. So once this is done, how do you take the input now? Now you have to define a letter S which will take your input. Okay. This should take your input. Now N is equal to S dot split. How will it split? It will split from the space. Okay. So name, age, grade, gender. These are the four attributes that you are considering, right? So what will you do? You will do L of 0, comma. You have to take this age as an integer input. So it will be L of 1, right? Then you will have L of 2. Then you will have L of 3. Okay. Once this is done, what are you going to do? You are comparing if age is greater than 20. If age is greater than 20, what will you do? You will append that name. You will append that name to the list, right? Now, if your gender is equal to female, right? If that is equal to female, then what will you do? You are going to do grade total plus is equal to, you are going to take the ASCII value of grade. Okay. This is the first step. The next step will be you are going to increment your total female by 1. Okay. The count will be incremented by 1. Now we'll calculate the average, which will be equal to grade total divided by total female. Correct? Now once this is done, we are going to print. What will we print? The answer, and we'll print the average. Correct? Now, before we run this, I am going to add in these lines. So this is something that you're not supposed to do, because this is how you need to take the input. Okay, your input has to be in this format. So now if we run this, say we entered 3 and then we entered a 21 a, then female, then we enter BBB. I don't remember the age. Was it probably 22? Then grade was B. Then it was a male. Then it was CCC. It was 24. Then it was grade C, and it was a female. Right? So if you do this, you will get AAAA, BBBB, CCCC, and 66. So if you go back, that was the output: AAA, BBB, CCC, and 66. Okay. So if you just want to change this to an integer division, and if you run this again, so I guess you will get 66. You won't get your 66.0. Okay. If you just exactly want to fetch the value. So this should be male. This was CCC and 24, grade C and female. Okay, all right, you got 66, no more point 0. So I just put these in for you so you know that you're not going to execute it in this way. All right. Now, what there are a few things that you need to consider. Often you need to consider how the input is taken. The input format is very important. Just take a look at that. Next, okay, we are not entering anything. Next is your basically the one is input type, the other one is optimization. Okay, it's very important how do you optimize. Okay, last but not the least, often you get a segmentation error while writing your code in TCS. That is because segmentation error because you're using few words or some function that is not defined in that compiler. So just so that you know, TCS has its own set of compilers that is designed by TCS itself. Okay, so you might end up in segmentation error. So try to use all the values, all the functions that are commonly known. Okay, do not go out of the box trying something new. Okay, use all those function, all those inbuilt function or keywords that are commonly used. Okay, so last but not the least, what will be your time complexity? Now time complexity is going to be a constant. Okay, and your space complexity will be big O of n. Why n? Because we are returning an array, but again this is debatable because we were asked to return this array, but still people will tell you that okay, you have to consider this to be big O of 1. Okay, so it is completely up to you. And just let's rerun this so you people don't think it's an error. It was just an keyword interrupt. So it's AAA 21 A and female. Then this is BBB 22 and B and male. Then CCC 24 B and female. All right. So you have this. So it's completely up to you whether you take a integer division or you just take division. So accordingly, your answer over here will change. Okay. So be sure of what you write. Be sure of all these things that I have told you. I hope that you can perform well with all these questions that we have solved so far. I wish you all the best. Keep learning. I will see you in the next one. Until then, thank you.